Close your eyes and imagine yourself standing at the entrance of a vast airport terminal. The air is cool and clean, filtered through hidden vents high above. The lighting is soft, almost golden, casting gentle shadows across the polished floor. And there, stretching before you like a ribbon of possibility, is an automatic walkway. You step onto it, and immediately you feel that subtle shift, that gentle forward momentum that requires nothing of you but surrender. The handrail moves beneath your palm at exactly the same speed as the belt beneath your feet, a perfect synchronization that took engineers decades to perfect. Let yourself relax into this movement. There's nowhere you need to be, nothing you need to do. Just ride along, and let me tell you the story of these remarkable paths. The walkway beneath you moves at approximately 1.4 miles per hour, though some can reach speeds of up to 2 miles per hour. This might seem slow, but it's the perfect pace, fast enough to help you on your journey, slow enough to feel safe and serene. The speed was chosen after countless studies of human comfort and balance. Engineers discovered that anything faster than 2 miles per hour made people feel unstable, their inner ears protesting the acceleration. But at this gentle pace, you can stand perfectly still or walk alongside the movement, doubling your speed without effort. As you glide forward, notice the sound. It's a low, consistent hum, the sound of hidden motors turning smoothly beneath the floor. These motors are usually located at one end of the walkway, typically the exit end, pulling the belt through a continuous loop like a giant conveyor belt. The sound is steady, unchanging, like a mechanical heartbeat. Let it lull you. Let it become part of your breathing rhythm. The very first moving walkway was unveiled to the world in 1893 at the World's Columbian Exposition in Chicago. It stretched along a pier at the lakefront, and thousands of people lined up to experience this marvel of the modern age. They called it a movable sidewalk back then, and it operated in 2 sections. The outer section moved at 2 miles per hour, while the inner section moved at 4 miles per hour, double the speed of most walkways today. Passengers would step onto the slower section first, then transition to the faster one, like stepping from a gentle stream into a faster current. Imagine those Victorian-era visitors, the women in their long skirts and elaborate hats, the men in their stiff collars and bowler hats, all stepping tentatively onto this moving miracle. The walkway ran for nearly half a mile along the water's edge, and people could sit on benches as they rode, watching the waves of Lake Michigan roll past. Some thought it was terrifying. Others thought it was the future. They were both right. You continue gliding forward on your own walkway now, and you notice the construction beneath your feet. The belt you're standing on is made of metal plates, usually steel or aluminum, linked together like the scales of a massive mechanical fish. Each plate overlaps with the next, creating a flexible surface that can bend around the curves of the machinery hidden below. These plates are textured, grooved in a diamond or checkerboard pattern to give your feet purchase, to keep you from slipping. The edges of the walkway are marked with yellow paint or yellow rubber bumpers, a universal warning that you're approaching the boundary. This yellow is carefully chosen, bright enough to catch attention even in dim lighting, but not so bright as to be jarring or alarming. It's the same yellow used on caution signs around the world, a color that speaks directly to the ancient parts of your brain that recognize warning in nature. The yellow of wasps, of poison dart frogs, of sunlight filtering through storm clouds. But you're safe here. You're perfectly centered on the belt, hands resting gently on the moving handrail. The handrail itself is a feat of engineering. It's made of a continuous loop of rubber, usually in black or dark gray, sometimes in a contrasting color. Inside this rubber exterior is a fabric-reinforced core that gives it strength and flexibility. The handrail moves through a track, guided by hidden wheels and pulleys, synchronized perfectly with the belt beneath your feet through a complex system of gears and sensors. In the early days of moving walkways, this synchronization was one of the greatest challenges. If the handrail moved even slightly faster or slower than the belt, people would lose their balance. Their hands would slide forward or drag backward, creating a moment of disorientation. Engineers spent years perfecting the tension systems, the gear ratios, the the sensor feedback loops that keep everything moving in harmony. Now, when you rest your hand on the rail, you don't even notice the movement. It's as natural as standing. Still, let yourself sink deeper into relaxation as you ride. Notice how your body has adjusted to the movement. Your muscles have learned this new pace, this forward glide that requires no effort. This is the gift of the automatic walkway. It carries you without asking anything in return. The walkway stretches, ahead of you, seemingly endless. In reality, the longest moving walkway in the world is in Hong Kong, running for nearly 2,600 feet, almost half a mile, through the central mid-levels district. It's actually a system of 20 interconnected walkways and escalators that climb more than 400 feet up the hillside, carrying commuters from the bustling streets below to the residential areas above. During morning hours, it runs downhill to help people get to work. In the afternoon and evening, it reverses direction, carrying tired workers back home. Imagine riding that entire journey, watching the city transform around you, from the glass towers of the financial district to the old apartment buildings with their bamboo scaffolding and hanging laundry, all while standing perfectly still. You pass by other travelers on your walkway. Some stand motionless like you, eyes half closed, perhaps listening to music through earphones or lost in their own thoughts. Others walk briskly along the moving belt, their speed doubled by the assistance of the mechanism beneath their feet. A few travelers move against the flow on the stationary floor beside the walkway, walking the traditional way. But you're content to simply glide, to let the machine do the work. The technology that makes this possible is simultaneously simple and complex. At its heart, an automatic walkway is just a large belt drive system, the same basic principle used in sewing machines and industrial conveyors. But the scale changes everything. The belt beneath you might weigh several tons, requiring powerful motors to keep it moving smoothly. These motors are typically electric, ranging from 5 to 15 horsepower, depending on the length and incline of the walkway. The motor drives a large drum, usually about 3 feet in diameter, that pulls the belt. This drum is covered in a high-friction material to grip the belt without slipping. As the drum rotates, it pulls the top surface of the belt forward and returns the bottom surface backward, creating that continuous loop. The belt passes over several smaller guide wheels along its length, wheels that keep it tracking straight and prevent it from wandering sideways. Everything is designed with redundancy and safety in mind. There are sensors that detect if someone falls, if clothing gets caught in the mechanism, if the belt starts to slip or stretch. Emergency stop buttons are positioned every few meters along the length of the walkway, bright red mushroom-shaped buttons that anyone can slap in a moment of crisis. When pressed, these buttons cut power to the motor instantly, though the belt doesn't stop immediately. The momentum of all that moving metal means it takes several seconds to coast to a complete halt, which is why the system is designed to slow gradually rather than stop abruptly. You've been riding for several minutes now, and the walkway continues ahead of you, straight as an arrow through the terminal. The architects who design these spaces think carefully about where to place moving walkways. They're most useful in long corridors where people need to cover significant distances, between terminal buildings, from parking garages to check-in counters through sprawling train stations. But they're also strategic tools for managing crowd flow. A moving walkway acts like a river, creating a channel where people naturally congregate and move together. This can help prevent bottlenecks and keep crowds moving smoothly through busy areas. But it can also create problems if not designed correctly. If a walkway ends at a point where people need to make decisions, which direction to turn, which gate to approach, it can create a pile-up as people hesitate while still being pushed forward by the flow behind them. Smart terminal designers create what they call decision zones at the end of walkways. Wider areas where the floor is stationary and people have room to pause, consult maps or signs, and orient themselves before moving on. You can see one ahead of you now, a broader space where the walkway ends and the regular floor begins. But you're not ready to step off yet. In your mind, this walkway continues forever, and you can ride it as long as you need. The gentle hum beneath you continues, unwavering. This sound comes from more than just the motor. It's also the whisper of metal plates sliding over the guide wheels, the soft friction of the handrail moving through its track, the subtle vibration of the entire structure as it works. Some people find the sound annoying, a mechanical intrusion, in spaces meant for human comfort. But to others, especially late at night when the terminal is quiet, it's a lullaby, proof that the machines are working, that the systems designed to move us safely through space are doing their job. The science of moving walkways intersects with fascinating areas of human psychology. Studies have shown that people behave differently on moving walkways than they do when walking normally. They stand closer together, more willing to tolerate proximity to strangers. They stare straight ahead more often, entering a slightly meditative state. Their stress levels, measured by heart rate and cortisol, tend to decrease. There's something about being moved by forces outside yourself that allows the mind to relax, to let go of the constant calculation and effort that walking requires. This is why airports use them not just for efficiency, but for comfort. After the stress of security checks and the anxiety of catching a flight, stepping onto a moving walkway offers a moment of peace. You don't have to think about your next step. You can just be suspended in movement. The walkway beneath you is probably inclined slightly upward or downward. Perfectly flat moving walkways are less common than you might think. Many are installed with gentle slopes, usually no more than 3 to 6 degrees, helping people climb or descend between different levels of a building. The engineering for an inclined walkway is more complex than for a flat one. The motor needs more power to pull the belt uphill against gravity and the weight of passengers. The belt needs more tension to prevent it from sagging in the middle. Extra safety mechanisms are required to prevent the belt from sliding backward if the motor fails. Some inclined walkways use a toothed belt system similar to an escalator, where metal cleats on the surface of the belt provide extra grip for passengers and extra security against slipping. You might have seen these in particularly steep installations. They look like a hybrid between a moving walkway and an escalator, with small ridges running across the width of the belt. The distinction between a moving walkway and an escalator is actually less clear than most people think. Both are types of people movers, a category that also includes moving sidewalks, travelators, and various experimental systems that never quite caught on. The key difference is that escalators are stairs that move, while walkways are belts that move. But there are many variations in between. Some walkways have slight ridges that make them almost like very flat stairs. Some escalators are so gently inclined that they're almost like walkways with steps. In the 1970s, several companies experimented with high-speed moving walkways, systems that could move at 4, 5, even 6 miles per hour. The challenge was getting people on and off safely at those speeds. Some designs used acceleration zones where the belt gradually sped up after you stepped on and gradually slowed down before you stepped off. Others used parallel belts moving at different speeds, so you could step from a slow belt to a fast belt to an even faster belt, like shifting gears in a car. The most ambitious of these was installed at the Osaka Expo in 1970. It could move at up to 5 miles per hour and had a complex system of accelerating and decelerating zones. But it was plagued with problems. People stumbled getting on and off. The acceleration made some riders nauseous. Maintenance was constant and expensive. After the expo ended, the system was dismantled, and the dream of high-speed moving walkways largely died with it. Today's walkways stick to that gentle 1.4 to 2 miles per hour pace, the speed that feels natural to human bodies, that doesn't trigger our instinctive fear of falling or our susceptibility to motion sickness. It's a speed that respects our biology, even as it augments our capabilities. You glide onward, breathing deeply, feeling the tension drain from your shoulders. The terminal around you is quiet now in your imagination. Perhaps it's late at night, or early in the morning before dawn. The shops are closed, their metal gates pulled down. The gates at the boarding areas are empty. A janitor pushes a floor polisher somewhere in the distance, its motor adding to the symphony of mechanical sounds that fill the space. The floor beneath the walkway, you notice, is perfectly smooth and clean. Keeping these systems clean is a challenge. Dirt, dust, and debris can work their way into the gaps between the metal plates, grinding against the moving parts, causing wear and tear. Most major terminals have cleaning protocols where the walkways are shut down in the middle of the night and thoroughly cleaned. Technicians use special vacuums to suck debris from the gaps. and they lubricate the moving parts with carefully chosen oils and greases that can withstand the constant motion and pressure. The handrails, too, need regular cleaning. They're touched by thousands of hands every day, each one leaving behind a microscopic layer of skin oils, dirt, and bacteria. The rubber surface is usually treated with antimicrobial agents, but it still needs to be wiped down regularly. Some terminals have automated systems that clean the handrails continuously as they move, using rotating brushes or chemical sprays, though these can be noisy and distracting for passengers. Maintenance crews also inspect the belt regularly for signs of wear. They look for stretched areas, for plates that have come loose or cracked, for any irregularity in the surface that might cause someone to trip. A well-maintained walkway can last for decades, but it requires constant attention. The belt itself might be replaced every 10 to 15 years, depending on usage. The motor and drive systems can last longer, though individual components, bearings, sensors, switches need periodic replacement. You've been riding for quite a while now, and you've covered an impressive distance, at least in your mind. The Walkway has carried you effortlessly, asking nothing of you but trust. And you've given it that trust, relaxing more deeply with each passing moment. Let's travel back in time for a moment to see how we arrived at this technology. The idea of a moving sidewalk captivated inventors in the late 19th century during the Great Age of Mechanical Innovation. These were the years when electricity was being harnessed, when internal combustion engines were being perfected, when machines were beginning to transform every aspect of human life. The 1893 Chicago World's Fair Walkway was a sensation, but it was also terribly unreliable. It broke down frequently, stranding passengers halfway along its length. The wooden platform would sometimes catch fire from the friction of the machinery below. But the concept was proven. People wanted this technology, even if it wasn't quite ready for widespread use. After Chicago, moving walkways appeared at other world's fairs and expositions. The 1900 Paris Exposition featured an even more elaborate system with multiple platforms moving at different speeds. Passengers could board a slow-moving platform, then step to a faster one, then to a faster one still, until they were moving at nearly 5 miles per hour through the exposition grounds. At the end of their journey, they would reverse the process, stepping down through slower and slower platforms until they could safely step off onto solid ground. These early systems were marvels of mechanical engineering, driven by enormous steam, engines housed in dedicated buildings. The machinery was loud, hot, and dangerous. Workers called it feeding the beast, the constant work of shoveling coal and maintaining steam pressure to keep the platforms moving. But the public loved it, and thousands of people paid extra admission fees just to ride the moving sidewalks. The technology remained a novelty for decades, too expensive and unreliable for everyday use. But gradually, as electric motors became more powerful and more efficient, as safety systems improved, moving walkways began to appear in practical settings. The first permanent installation in a transit setting was probably at the Bank Underground station in London in 1960, a short walkway helping passengers navigate between platforms. It was quickly followed by installations at major airports, starting with Pier B at Newark Airport in 1964. The 1960s and 70s were the golden age of moving walkway installation. Airports were expanding rapidly to accommodate the jet age, with terminals growing larger and more spread out. Walking from one end of these mega terminals to the other could take 15 or 20 minutes. Moving walkways cut that time in half and made the journey much less exhausting for travelers carrying heavy bags or managing children. The walkway beneath you now represents decades of refinement. Everything about it, the speed, the width, the height of the handrails, the texture of the belt, has been optimized through years of observation and adjustment. The standard width is usually about 3.3 feet for a one-lane walkway or about 6.5 feet for a two-lane system. This width is calculated to allow one person to stand comfortably or two people to walk side by side with enough space that they don't feel crowded or at risk of brushing against the edges. The height of the handrails is typically about 35 to 40 inches from the surface of the belt, a height that accommodates most adults without requiring them to reach up or bend down. Children often can't reach the handrails comfortably, which is why you sometimes see warning signs asking parents to hold their children's hands while riding. The yellow warning strips at the edges are exactly 2 inches wide in most installations, a width that's highly visible without taking up too much of the belt's usable surface. These strips are often made of a slightly different material than the rest of the belt, sometimes rubber instead of metal, or a rougher texture, so they can be detected by feel as well as sight. This helps visually impaired passengers navigate the walkway safely. Speaking of accessibility, moving walkways are actually one of the more accessible forms of mechanized transit. Unlike escalators, which can be difficult or impossible for people using wheelchairs or walkers, moving walkways can often accommodate wheeled mobility devices as long as the incline isn't too steep. Many airports specifically route accessible paths through moving walkways rather than around them, recognizing that the mechanical assistance is valuable for people with limited mobility. However, not all walkways are created equal when it comes to accessibility. The transition zones at the beginning and end of the walkway, where the moving belt meets the stationary floor, can be challenging. There's a small gap, usually less than 1 inch wide, between the moving and stationary sections. For most people, this gap is barely noticeable. But for someone using a wheelchair or a walker with small wheels, it can be a significant obstacle. Better designed walkways use what's called a comb plate at the transitions, a series of interlocking teeth that minimize the gap while still allowing the belt to move freely. You're approaching one of these transition zones now in your mind. The end of the walkway is ahead, marked by yellow warning stripes and signs reminding you to watch your step. But instead of stepping off, imagine that the walkway continues, that it loops back on itself, that you can ride it indefinitely. Because in this story, that's exactly what happens. The walkway is infinite, a perpetual motion machine carrying you through space and time. As you ride, think about the energy required to keep this system moving. A typical airport moving walkway might consume 5 to 10 kilowatts of electricity when running at full capacity, about the same as running 50 to 100 traditional incandescent light bulbs. Multiply that by all the walkways in an airport running 24 hours a day, 365 days a year, and the energy consumption becomes significant. This is why many modern walkways are equipped with sensors that detect when passengers are present. If the sensor detects no one on the walkway for more than 30 seconds or so, the system can slow down or even stop completely, conserving energy. When someone approaches, the sensor detects their presence and the walkway accelerates back to operating speed within a few seconds. This can cut energy consumption by 30 to 50% in off-peak hours. Some cutting-edge installations use regenerative braking systems, similar to those in hybrid cars. When the walkway is going downhill, gravity helps pull the belt along, and the motor can actually work in reverse, acting as a generator that feeds electricity back into the building's power grid. The amount of energy recovered is small, but over years of operation, it can add up to significant savings. There are also experiments with solar-powered walkways, especially in outdoor installations. Photovoltaic panels can be integrated into the roof structures that often cover walkways, generating electricity during the day that can offset some of the power consumption. In sunny climates, these systems can approach energy neutrality, producing almost as much power as they consume. But for now, the walkway beneath you hums along on grid power, reliable and steady. The machinery doesn't care whether it's day or night, summer or winter. It simply continues its appointed task, moving the belt forward in an endless loop. Let your mind wander now to other kinds of moving walkways, variations on this theme. In some airports, you'll find walkways enclosed in glass tubes like transparent tunnels cutting through the terminal. These can be quite dramatic, especially when they connect different buildings or cross over open spaces. There's a famous one at the Detroit airport, a walkway enclosed in a tunnel with constantly changing colored lights and ambient music, transforming the utilitarian task of getting from one concourse to another into an immersive experience. In some cities, moving walkways have been installed outdoors, covered by roofs but open to the air on the sides. These can be found in hillside communities where steep streets make walking difficult, or in business districts where they help workers commute between office buildings. The engineering challenges for outdoor walkways are significant. They must withstand rain, snow, ice, extreme heat, and the debris that wind can blow onto the belt. Special drainage systems are required to keep water from pooling on the belt, and heating elements may be needed to prevent ice from forming in winter. There are even moving walkways underwater in aquarium tunnels where you can stand still and be carried past enormous tanks of marine life. The walkway moves slowly, giving you time to see the fish and sharks and rays swimming past, while preventing bottlenecks as visitors stop to stare. The glass tunnel curves around you, water on all sides, and the gentle forward motion creates a dreamy, floating sensation. In your mind now, transform the walkway beneath you into one of these aquarium walkways. The terminal around you fades, replaced by deep blue water. Light filters down from above, shifting and dancing with the movement of the waves on the surface far overhead. You glide forward, and a sea turtle paddles past, its flippers moving in slow, powerful strokes. A school of silvery fish flows around you like a living river. The mechanical hum of the walkway blends with the gentle bubbling and rushing of water, creating a soundscape that's both artificial and natural, technological and organic. But whether in an airport, a museum, a train station, or an aquarium, the fundamental experience of a moving walkway remains the same. You surrender yourself to the mechanism, you trust it to carry you forward, and in that surrender, in that trust, there's a peculiar kind of peace. This is different from the experience of riding in a car or a train, where you're enclosed and isolated from your surroundings. On a moving walkway, you're still exposed to the space around you. You can see and hear and smell everything as you would if you were walking normally. But you're freed from the effort of walking, from the need to watch where you place each foot, from the mental calculation of pace and balance. Your consciousness can drift, can observe, can rest. Researchers who study attention and cognition have found that this state, being in motion without effort, can actually enhance certain types of thinking. Creative problem solving, for instance, seems to benefit from gentle, steady movement. There's something about the rhythm of movement that helps the mind make connections, that allows ideas to flow more freely. This is why people often think of solutions while taking a shower or walking, or in this case, riding a moving walkway through an airport terminal. The ancient Greeks called this peripatetic thinking, the practice of walking while thinking. Aristotle famously taught his students while walking the covered paths of the Lyceum in Athens. But the Greeks could never have imagined being carried along while thinking of movement without effort, of peripatetic thinking without the peripatetic part. The walkway continues beneath you, and you continue to relax, breathing deeply and evenly. Your heart rate has slowed. Your muscles have released their tension. You're in that borderland between waking and sleeping, aware but not alert, conscious but not focused. Let's consider the materials that make up the walkway beneath you. The belt plates are typically made of stainless steel or aluminum alloy, chosen for their combination of strength, durability, and resistance to corrosion. Airports are surprisingly corrosive environments. The salt used to melt ice on runways gets tracked inside on shoes and luggage. Spilled drinks, cleaning chemicals, and the simple moisture from thousands of breathing passengers all take their toll on metal surfaces. Stainless steel resists this corrosion better than almost any other practical material, maintaining its structural integrity and appearance for years. The specific alloy is usually something like 304 or 316 stainless steel, the same materials used in kitchen appliances and medical equipment. These alloys contain chromium, which forms an invisible layer of chromium oxide on the surface, protecting the underlying metal from rust and degradation. The texture on the belt plates, those diamond patterns or raised dots, is created during manufacturing, either by casting the plates in molds that have the pattern, or by pressing the pattern into flat plates using enormous hydraulic presses. The depth of the texture is carefully controlled, deep enough to provide grip, but not so deep that it becomes difficult to clean or that it causes discomfort when people sit down on the belt. Yes, despite all the signs asking people not to sit on moving walkways, people do it anyway. Parents let their children sit. Tired travelers plop down their bags and themselves. From an engineering standpoint, this is actually not a problem. The belt is designed to carry far more weight than the maximum number of people who could reasonably fit on it. But from a safety standpoint, sitting increases the risk of getting clothing or bags caught in the machinery at the transition zones, which is why it's discouraged. The handrail you're gripping lightly is a marvel of chemistry and engineering. The rubber compound used in handrails is specially formulated to balance several competing requirements. It needs to be soft enough to grip comfortably, but hard enough to resist wear. It needs to be flexible enough to bend around the pulleys and curves of the track, but stiff enough not to stretch over time. It needs to resist degradation from UV light, ozone, oils from human skin, and cleaning chemicals. Most handrails use a type of rubber called neoprene, or a blend of neoprene with other synthetic rubbers. Neoprene was originally developed by DuPont in the 1930s as one of the first successful synthetic rubbers. It's resistant to oil, heat, and weathering, making it ideal for applications like handrails where durability is paramount. Inside the rubber exterior, the handrail usually has a core of fabric cords, often made of aramid fibers like Kevlar, the same material used in bulletproof vests. These cords give the handrail tensile strength, preventing it from stretching even. After millions of cycles of movement, the color of the handrail is a deliberate choice. Black is most common because it doesn't show dirt as readily as lighter colors, and because the carbon black pigment used to create the color actually improves the rubber's resistance to UV degradation. Some walkways use gray or even blue handrails, colors chosen to match the overall design scheme of the terminal, but these require more frequent cleaning to maintain their appearance. As the handrail moves through its track, it passes through sets of brushes and guides that keep it centered and remove loose debris. In some systems, these brushes are also impregnated with cleaning compounds that continuously polish and sanitize the surface. The track itself is usually made of plastic or aluminum, smooth and low friction, to allow the handrail to slide along easily. The entire handrail assembly is balanced by a tensioning system, usually a weighted pulley or a spring mechanism that keeps constant pressure on the rubber loop. This is necessary because rubber, even high-quality synthetic rubber, will stretch slightly over time and with temperature changes. The tensioning system automatically adjusts, taking up slack to ensure the handrail always moves smoothly and stays synchronized with the belt. You're still gliding forward, the walkway an extension of your body now, so familiar that you don't notice the movement anymore. This is the ultimate achievement of good design. Technology that becomes invisible, that disappears into the background of experience. Think about how many people have stood exactly where you're standing now. How many hands have touched this handrail? How many feet have rested on these plates? A busy airport walkway might carry 10,000 people per day, more than 3.5 million per year. Over a decade, that's 35 million individual journeys, each one unique, each one a small story of someone going somewhere. Some of those people were heading home after a long trip, exhausted but content. Some were leaving home for the first time, nervous and excited. Some were rushing to make a connection, stressed and sweating. Some were walking slowly, savoring the last moments before saying goodbye to someone they loved. Some were alone. Some were in groups, laughing and chatting. Some were crying. Some were sleeping on their feet, so tired that even the movement of the walkway couldn't quite wake them. Each of these millions of people trusted the walkway, just as you're trusting it now. They stepped on, they rode, they stepped off, and the mechanism carried them faithfully every time. This reliability is perhaps the most remarkable thing about moving walkways. They're so dependable that we barely think about them, so consistent that they fade into the background of our consciousness. This reliability comes at a cost of constant maintenance and monitoring. In the control rooms of major airports, banks of monitors display the status of every moving walkway in the facility. Sensors report on motor temperature, belt speed, electrical current draw, and dozens of other parameters. If any reading goes outside normal range, alarms sound, and maintenance crews are dispatched immediately. Most problems are minor. A piece of luggage jammed in the mechanism, the emergency stop button pressed accidentally, a sensor giving a false alarm. But occasionally, more serious issues arise. A motor might overheat, a belt might begin to slip, a bearing might start to fail, creating a grinding sound and generating excessive heat. The sophisticated monitoring systems are designed to catch these problems early before they lead to complete failure or worse, injury to passengers. The safety record of moving walkways is actually remarkably good. Injuries are rare, and serious injuries are even rarer. Most incidents involve people tripping while getting on or off, usually because they weren't paying attention or were distracted by phones or conversations. This is why airports install so many warning signs and why the transition zones are marked so clearly with yellow paint and lights. There have been notable failures over the years, incidents that led to improved safety standards. In 1987, a moving walkway at London's King's Cross Station caught fire, contributing to a larger fire that killed 31 people. The incident led to new regulations requiring fire-resistant materials in escalators and moving walkways, and better emergency procedures for underground stations. In 2003, a moving walkway at the Cincinnati airport suddenly reversed direction, sending passengers tumbling backward. The incident was caused by a mechanical failure in the braking system. No one was seriously hurt, but it led to new requirements for redundant braking systems that make such reversals virtually impossible. These incidents are exceptions in a technology that has carried billions of passengers safely over more than a century of operation. But they serve as reminders that these machines, for all their reliability, require respect and attention. They're powerful systems, moving tons of metal and people, and they demand proper maintenance and careful design. The walkway beneath you continues its smooth, steady motion, untroubled by the history of the technology, unconcerned with the challenges of the past or future. It exists in an eternal present, always moving, always the same. The motor hums, the belt slides forward, the handrail glides through its track. Over and over, endlessly. Imagine now that you've been riding this walkway for hours. The terminal has transformed around you. Dawn has broken and golden light streams through the tall windows. The shops are opening, their metal gates rolling, up with a clatter. The smell of coffee and pastries drifts from a cafe. Announcements echo from the PA system, calling flights, welcoming passengers. But you remain on the walkway, gliding past all this activity in your bubble of mechanical motion. People board the walkway behind you and exit ahead of you, but you remain, a constant presence, riding the endless belt. The technology of moving walkways hasn't changed dramatically in the past few decades. The fundamental design is mature, optimized, proven. But there are always researchers and engineers imagining what might come next. Some envision walkways that can change speed based on passenger load, moving faster when empty and slowing down when crowded. Others imagine walkways that can adapt to individual passengers, speeding up for those in a hurry and slowing down for those who need more time. There are concepts for walkways with built-in seating, rows of benches that move along with the belt, allowing tired travelers to sit and rest while still making progress toward their destination. This was actually tried in some early moving sidewalks, but abandoned because the benches took up too much space and reduced the overall capacity of the system. Some futurists imagine moving walkways integrated with augmented reality systems, where passengers wearing AR glasses could see virtual information floating in their field of view, directions to their gate, information about nearby restaurants and shops, even entertainment content to make the journey more interesting. The walkway would know where each passenger needed to go and could adjust their path accordingly, speeding up or slowing down, or even branching to different routes. But for now, the walkway remains beautifully simple. It's a belt that moves. You step on, you ride, you step off. Nothing more, nothing less. And in that simplicity is a kind of perfection. The rhythm of your breathing has synchronized with the motion of the walkway. Each inhale lasts exactly as long as it takes the belt to advance one plate length forward. Each exhale matches the movement of another plate. You're breathing with the machine, merging your biology with its mechanics. This is a kind of meditation, this riding of the walkway. Your mind has quieted. Thoughts arise and pass like passengers boarding and exiting around you. You don't grasp at them or push them away. You simply observe, letting everything flow past. The airport terminal in your imagination has become vast, cathedral-like. The ceiling arch is high overhead, supported by slender columns of steel and glass. Light filters down from above, creating geometric patterns on the floor. The walkway stretches ahead of you to a vanishing point, so far in the distance that you can't see where it ends. You might wonder, in this peaceful state, about the first person who thought of this technology. Was it someone tired of walking? Someone who dreamed of being carried along? Or was it an engineer, someone who saw the possibility of applying conveyor belt technology to human transport? We don't know for certain. The idea seems to have occurred to multiple inventors independently in the late 19th century, as it does with many technologies when the time is right. What we do know is that the concept captured imaginations immediately. Moving sidewalks appeared in science fiction stories and futuristic illustrations throughout the early 20th century. Artists imagined cities where all the sidewalks moved, where people never walked but were always carried by networks of belts, moving at different speeds. Some visions showed multi-level cities where slow walkways connected to medium walkways connected to fast walkways, creating an intricate circulatory system for human traffic. These visions never came to pass. At least, not yet. The economics don't make sense for most cities. Moving sidewalks are expensive to install and maintain, and they work best in specific situations like long corridors or steep hills. Regular walking is free, requires no infrastructure, and offers health benefits that being carried doesn't provide. But in certain contexts, moving walkways have become indispensable. Try to imagine a modern airport without them. The terminals would need to be smaller, or travelers would need much more time to make connections, or there would need to be more shuttle vehicles moving people between concourses. The moving walkway solves a specific problem elegantly. How to move large numbers of people moderate distances without the expense and complexity of trains or buses. The walkway beneath you represents a sweet spot in transportation technology, a niche perfectly filled. It's not appropriate for traveling miles, like a train or bus. It's not necessary for crossing a room, like your own feet. But for those in-between distances, those long corridors and terminals and passages, it's ideal. You glide on, relaxed now, beyond measure. Your muscles have released every last bit of tension. Your mind has drifted into a state between sleep and waking, where awareness persists, but thought has faded. The sound of the walkway, that steady hum, has become like silence, so constant that your brain filters it out. You're aware of it only when you pay attention deliberately, and when you stop paying attention, it recedes again into the background. This is how we adapt to technology. At first, it's novel and demanding of our attention. Then it becomes familiar. Finally, it becomes invisible, woven so tightly into the fabric of our lives that we only notice it when it's absent. Imagine the walkway stopping suddenly. The silence would be startling. The stillness would be disorienting. You've become so accustomed to the motion that its absence would feel like a void, something missing from the world. But the walkway doesn't stop. It continues, reliable as sunrise, steady as your heartbeat. The motors turn, the belts move. The system functions exactly as designed, hour after hour, day after day. In this way, the moving walkway is a small miracle of modern civilization. It's infrastructure that works, technology that serves without demanding attention, design that succeeds by becoming invisible. It asks nothing of you except that you step on and let it carry you, and so you ride, peaceful and relaxed, your breathing deep and slow, your mind quiet. The terminal around you could be any terminal, anywhere in the world. They're all similar in the ways that matter. The same type of walkways, the same gentle forward motion, the same reliable technology. You could be in Singapore's Changi Airport, riding beneath the kinetic rain sculpture in Terminal 1, water droplets falling in synchronized patterns above you. You could be in Dubai, gliding past luxury shops displaying designer clothes and jewelry. You could be in Atlanta, in one of the busiest airports in the world, surrounded by thousands of other travelers, all moving through the space like blood cells through arteries. Or you could be in a small regional airport where the single moving walkway is the one gesture toward the amenities of larger hubs connecting the parking garage to the terminal building. The technology doesn't care about the context. It functions the same whether it's carrying 10 people per day or 10,000. The democratic nature of moving walkways is worth noting. Unlike first-class lounges or priority boarding, moving walkways are available to everyone. The business traveler in an expensive suit rides the same belt as the backpacker in worn jeans. The elderly woman with a walker glides at the same pace as the young athlete rushing to a competition. For a few moments, everyone moves together, equals in motion. This universal accessibility is actually a requirement in most airports. As public infrastructure, moving walkways must comply with accessibility regulations that ensure they can be used by people with disabilities. This means careful attention to the transition zones, to the height and design of handrails, to the width of the belt, to the clarity of signage. These regulations emerged from hard-won civil rights battles, from the recognition that infrastructure shapes society, that the built environment can include or exclude, enable or disable. A moving walkway that can't accommodate a wheelchair isn't just inconvenient. It's a barrier, a statement that some people don't belong in that space. Modern walkways are designed from the beginning with accessibility in mind. The gap between the moving belt and the stationary floor is minimized. The transition is as smooth as engineering can make it. The belt is wide enough for wheelchairs and mobility scooters. The incline is gentle enough not to pose a risk. This represents an evolution in thinking about public space and public infrastructure. Earlier generations might have designed moving walkways for the average person, whoever that might be, and considered accessibility an afterthought or add-on. Now, universal design principles suggest that infrastructure should work for everyone from the start, that accessibility benefits all users. After all, a walkway that's safe and easy for someone using a wheelchair is also safer and easier for parents with strollers, for travelers pulling heavy luggage, for anyone dealing with temporary mobility challenges from an injury or illness. The walkway carries you forward, asking nothing, judging nothing, available to all. It's a small thread in the larger fabric of civilization, one of thousands of systems and technologies that work quietly in the background to make modern life possible. Think about the chain of technologies required to make this simple ride possible. The electricity powering the motor probably comes from a power plant miles away, transmitted through a grid of wires and transformers. The steel in the belt was mined as iron ore, smelted in a blast furnace, alloyed with other metals, rolled into sheets, cut to size and stamped into shape. The rubber in the handrail began as crude oil, refined and processed through complex chemistry into synthetic polymers. The motor itself contains copper wire, rare earth magnets, precision bearings, all manufactured to exacting specifications. The control systems include sensors, computer chips, software written by programmers who probably never rode this particular walkway, but whose code keeps it running safely. This single moving walkway is the product of thousands of people's labor, expertise, and ingenuity. Miners and metallurgists, chemists and engineers, designers and installers, programmers and maintenance workers, all of them contributed to this moment, to your peaceful ride through the terminal. And none of them are here now. You ride alone, or perhaps surrounded by other travelers. But all those who made this possible are absent, invisible, known only through the functioning of their creation. This is the nature of infrastructure. It's the accumulated work of countless people, solidified into systems that persist across time. The people who installed this walkway might be retired now, or working on other projects, or perhaps no longer living. But their work remains, carrying passengers year after year. You're grateful for their efforts, for all the thought and care that went into making this simple ride possible. The gratitude is quiet, not demanding expression, just a gentle acknowledgement that you're benefiting from the labor and intelligence of people you'll never meet. The walkway continues. Your breathing continues. The gentle hum of the motor continues. Everything flows forward, steady and peaceful. Let your awareness expand now beyond the walkway itself to the larger patterns of movement in the terminal. There are other walkways, parallel to yours, carrying people in the opposite direction. There are escalators moving people between floors. There are elevators rising and falling. There are baggage conveyors beneath the terminal, carrying luggage in complex paths between check-in counters and aircraft. All of these systems are variations on the same basic technology: belts and motors, pulleys and controls, mechanics and electricity working together to move things from one place to another. The airport is a machine for moving people and objects, and the moving walkway is one component in this larger mechanism. If you could see a time-lapse of the airport over 24 hours, you'd see patterns emerge, waves of people flowing through the terminal as flights arrive and depart. peaks of activity in the morning and evening, quieter periods in the middle of the night. The walkways carrying their endless stream of passengers, adapting to the rhythm of the day. During peak hours, the walkway is crowded, people standing shoulder to shoulder with another lane of people walking alongside them on the belt. The system operates at maximum capacity, but it handles the load smoothly. The motor doesn't strain or complain, the belt doesn't slow down. The design includes enough safety margin that even full capacity is well within the system's capabilities. During quiet hours, the walkway might carry only a handful of people per minute. Some of those energy-saving sensors might kick in, slowing or stopping the belt until someone approaches. But whether busy or empty, the walkway performs its function without variation, without preference, without fatigue. Machines don't tire, at least not in the way living things do. They wear out gradually, components degrading microscopically with each cycle of operation, but they don't experience the exhaustion that comes from repetitive work. The walkway carries its millionth passenger with the same effort as its first. There's something profound in this, something that speaks to the difference between the mechanical and the organic, between the made and the born. You, riding the walkway, are a living being, complex and fragile, requiring food and rest, subject to illness and injury and eventual death. The walkway is a thing, simple in its essence despite its complex construction, requiring only electricity and maintenance, degrading slowly but predictably, replaceable in parts or as a whole. And yet in this moment, you and the walkway are partners. It moves you through space. You trust it with your safety and your journey. There's a relationship here, even if it's asymmetric, even if the walkway has no awareness of your existence. This relationship between humans and machines is one of the defining features of modern life. We're surrounded by tools and technologies that extend our capabilities, that allow us to do things that would be impossible with our bodies alone. The moving walkway is a small example, but it's part of a larger pattern. We create machines to serve us, and in serving us, they shape how we live and move and think. Some critics worry about this dependence on technology. They ask, what happens when we forget how to do things for ourselves, when we've outsourced so much of our capability to machines? If all the walkways stopped, would we remember how to walk long distances? If all the elevators stopped, could we still climb stairs? These are valid concerns, but they miss something important. The moving walkway doesn't make you forget how to walk. It complements your walking, extends it, makes longer journeys possible or easier. You still have your legs. You still know how to use them. You're choosing to ride the walkway, but you could choose to walk beside it if you wanted. Technology, when designed well, doesn't replace human capability, but amplifies it. The walkway amplifies your ability to cover distance. It takes your natural walking speed of, say, 3 miles per hour and adds its own 1.4 miles per hour, giving you a combined speed of 4.4 miles per hour if you choose to walk on the moving belt. That's almost a 50% increase in efficiency with no additional effort on your part. Or, as you're doing now, you can stand still and let the walkway do all the work, conserving your energy for when you'll need it later, when you're rushing to your gate, or exploring a new city after you land, or carrying heavy bags up to your hotel room. This choice, this flexibility, is the real gift of technology. It gives you options. It expands the space of what's possible. The walkway, beneath you, represents freedom, paradoxically, through its mechanical determinism. Yes, it moves along a fixed path at a fixed speed, following the commands of its programming without deviation. But by doing so reliably, it frees you from having to think about that aspect of your journey. You know the walkway will carry you from point A to point B, so you can think about other things, plan your next steps, or simply rest and observe. In a world full of uncertainty, there's comfort in things that work predictably. The sun rises in the east, water flows downhill, and moving walkways carry you forward at 1.4 miles per hour. These constants, natural and artificial, create a framework within which we can navigate uncertainty. You continue riding, your mind, drifting through these thoughts like clouds across the sky, nothing urgent, nothing demanding attention. Just quiet contemplation, easy and effortless as the motion of the walkway. The terminal around you has transformed again. It's evening now. The light outside the windows fading from blue to purple to black. The interior lights glow warmly, reflecting off the polished floor. The crowds have thinned. The pace has slowed. Even the announcements seem quieter, less urgent. This is a peaceful time in an airport, this transition from day to night. The energy changes. People are less rushed, more resigned to their journeys. They settle into seats at gates, into chairs at restaurants, finding ways to rest while waiting, and you ride the walkway, part of this larger pattern of waiting and movement, of rushing and resting, of journey and arrival. You're going somewhere, presumably, but right now, the journey itself is enough. The destination can wait. The walkway will get you there in its own good time. There's a lesson in this, perhaps, that sometimes the journey matters more than the destination. That the process of moving through space and time has its own value, beyond reaching a particular endpoint. The walkway doesn't care where you're going. It's designed to serve everyone equally, whether you're headed to an international flight or just to a restroom on the other side of the terminal. In this democracy of motion, your purpose matters less than your presence. You're here, on the walkway, moving forward, and that's enough. The motor hums, the belt slides, the handrail glides, your breathing deepens, your eyes grow heavy. The boundary between waking and sleeping grows thinner, more permeable. Maybe you're not in an airport at all, anymore. Maybe you're in a dream of an airport, riding a dream of a moving walkway. The details have grown fuzzy, indistinct. What's real is just the motion, the gentle forward glide, the sense of being carried towards something, somewhere, somehow. The walkway stretches ahead and behind, infinite in both directions. You've been riding forever, and you'll ride forever. More. Time has lost its meaning. There's only the eternal present of the ride, the now that never ends. You're so relaxed now that you're hardly aware of your body. It's become part of the walkway, merged with the mechanism. You're the walkway walking itself, the motor humming itself, the belt belting itself. Subject and object have dissolved. There's only the action, the movement, the forward flow. In Buddhist meditation, they speak of losing the self, of dissolving the boundary between observer and observed. In Taoist philosophy, there's the concept of Wu Wei, effortless action, being moved by the natural flow of things rather than forcing outcomes through will and effort. The moving walkway is Wu Wei made mechanical. It moves without forcing, without strain. It carries you without grasping. You ride without resisting, without struggling. Everything happens in perfect harmony, with minimum effort and maximum effect. This is the wisdom of good design, the philosophy embedded in engineering. Work with nature, not against it. The walkway accepts gravity, friction, inertia, and works within those constraints rather than trying to overcome them. The speed is chosen to match human comfort. The handrails synchronize with the belt. Every element is in balance, in harmony. And you, riding the walkway, are part of that harmony. Your weight on the belt is calculated into the system's design. Your hand on the rail is anticipated in the tensioning mechanism. You're not a foreign object imposing on the machine. You're an integral part of how it functions, the reason for its existence. Without passengers, the walkway is just machinery, turning pointlessly in an empty corridor. But with you aboard, it becomes meaningful, purposeful. It's fulfilling its function, doing what it was designed to do. You complete it, in a sense. You make it whole. This mutual completion, human and machine, passenger and walkway, is a small model of how technology and humanity can coexist. Not in opposition, not with technology dominating humanity or humanity rejecting technology, but in partnership, each bringing something essential to the relationship. The walkway brings reliability, efficiency, tirelessness. You bring purpose, direction, meaning. Together, you travel forward, accomplishing what neither could accomplish alone. Well, you could walk the distance yourself, but not as easily, not as restfully. And the walkway could run empty, but to what purpose? So you ride together, partners in motion, moving through the terminal toward whatever awaits at the end of the journey. The motor hums its mechanical lullaby. The belt carries you steadily onward. Your breathing slows to match the rhythm. Your thoughts drift like leaves on a stream. You're so peaceful now, so relaxed, so completely at ease. The walkway has become your entire world, the only reality that matters. Everything else, your past, your future, your worries and hopes and plans, has faded into insignificance. There's only this moment, this eternal now of forward motion. The terminal around you has transformed once more, or perhaps it was never there at all. You're riding the walkway through a vast, empty space, dark except for the walkway itself, which glows softly from within. The walls and ceiling have receded into shadow, into nothingness. There's only the path, illuminated, carrying you forward, into the gentle dark. This is the final transformation, the dissolution of everything except the essential experience of being carried, of moving without effort, of trusting the mechanism to take you where you need to go. And where is that? Where are you going? Does it matter anymore? The journey has become its own destination. The act of riding has become its own purpose. You're going nowhere and everywhere at once, traveling through space without moving, moving through time without traveling. The walkway carries you on and on and on into the deep peace of surrender, into the profound rest of letting go, into the gentle sleep that rises up to meet you like a soft, dark tide. The motor hums. The belt moves. Your breathing slows. Your consciousness dims. You're sinking now. Sinking into sleep. Carried by the walkway into dreams. And still it moves, reliable and steady. The eternal walkway. The endless path, carrying you gently, safely, peacefully forward into the night, into rest, into sleep. The motor hums, the belt moves, you sleep, and the walkway carries on as it always has, as it always will, forever forward, forever moving, forever carrying its precious cargo of dreams and dreamers into the endless, gentle night. Sleep now. Sleep. The walkway will carry you. Just sleep.